In this video, we are going to talk about how to use trig substitutions to help us integrate different types of expressions. They work best when you're in one of these three formats. You're talking about a square root, and you either have a squared minus u squared, where u is the variable, square root of a squared plus u squared, or the square root of u squared minus a squared. And we're going to see how we can really turn this into a massive substitution problem to help us integrate whatever the expression is. So if we're looking at an integral that's the square root of a squared minus u squared, and let's say we have tried a u substitution and all these other different techniques that we have under our belt and nothing else works, this is where we would try this technique. So we're kind of ranking things in order of the easiest things to try to the more difficult things to try. So if we're looking at something integrating like this, what trig substitution are we going to use? We're going to let u equal a sine of theta. So then we could build a right triangle by solving this for sine. So we have u over a is equal to the sine of theta. And that's going to give us enough information to build this right triangle using right triangle trig. Remember SOHCAHTOA for right triangle trig. Sine is the opposite over the hypotenuse. So if my theta is here when I draw my triangle, sine is opposite. So there's my u, opposite over the hypotenuse, which is a. I could find this using Pythagorean theorem. If I don't know what this side is, I'll call it b. Pythagorean theorem would say this side squared plus this side squared is equal to that hypotenuse squared. And then to solve for b, I would subtract the u squared, and then I would take the square root. Now, because we're dealing with trig functions, and we're talking about dealing with possibly inverse trig functions, we have to put domain restrictions on our theta values. If we're using sine here, inverse sine is defined from negative pi over 2 to pi over 2. So that's where that domain restriction is coming from here. So then where would this guy come from? If we're using this right triangle, remember cosine is adjacent divided by hypotenuse. So adjacent would be that square root of a squared minus u squared. Hypotenuse would be a. So you can see if I solve that for that square root, I'm going to get a cosine of theta. And the same thing's going to be true with the other ones. If we have something that's in the form of square root of a squared plus u squared, we could use the tangent function. So this is equivalent to saying u over a is equal to the tangent of theta. Tangent is opposite over hypotenuse. So if this is my theta for my right triangle, my opposite is u. My adjacent is a. I'm not sure if I said hypotenuse earlier. I meant opposite over adjacent. So then to find this side, Pythagorean theorem would give us the square root of a squared plus u squared. We know tangents and secants go together, just like we know sines and cosines go together. So if I were to find the secant of this, that's the same thing as 1 over cosine. And remember, cosine is adjacent over hypotenuse. So that means secant is hypotenuse divided by adjacent. So hypotenuse divided by adjacent in that triangle would be this. So that's equal to the secant. So if I multiply both sides by a, then that's where this substitution would come from, right here. And then we could do the same thing for inverse, for this guy with secant. If we're in the form of square root of u squared minus a squared, we're going to use the secant function. So we're going to have u over a is equal to secant of theta. And then we could build our triangle just like we talked about before. So secant is the same thing as 1 over cosine. So that means A over U is equal to cosine of theta. So that's the adjacent over the hypotenuse. This would be found using the Pythagorean theorem. We know secants and tangents go together. So the tangent of theta is going to be equal to opposite over adjacent, square root of u squared minus a squared over a. So a tangent of theta is equal to the square root of u squared minus a squared. So that's where that substitution is coming from. Now it really depends on where our theta value lives. If our theta value is in that first quadrant, we would use a positive a. If it is in the second quadrant, we would use a negative a. So there are some limitations that come with using this technique because we have to limit theta due to inverse trig functions. But for the most part, it works out pretty well. So what do you need to remember? You really just need to remember these three formats: a squared minus u squared. Let's try u equals a sine of theta. So then u over a is equal to sine of theta, and that gives you enough information to build a triangle. If we're in the format a squared plus u squared, then we're going to use u equals a tangent of theta, which means u over a is equal to tangent. And then if we're in the form of u squared minus a squared, then we're going to have u equals a secant theta. So u over a is equal to secant of theta. So let's look at a few examples. Let's say we want to integrate 1 over the square root of 64 minus x squared to the third. We're integrating with respect to x. So you can see how a u substitution is not really going to help us. If our u is that radicand, that's 64 minus x squared, then du would be negative 2x, and we don't have any x's up here. So this is where you may want to try integrating with a trig substitution. So I'm going to rewrite this. I'm taking the square root of something that is to the third power. So I could think about it as the square root of 64 minus x squared and that whole thing being to the third power. And that's where my u substitution is going to come in at. This is in that first format, a squared minus u squared. So we are going to let, and since I have x's in here, I'm going to use x instead of u. X equals a sine of theta. My a would be 8. So we have a squared minus u squared, and that's going to be u equals a sine of theta. So that's the format we're using. A is going to be 8 because it's whatever I have to square to get that 64, and I'm just using x for the u. So that means x over 8 is equal to sine of theta. That's enough information to build a triangle. So let's build our right triangle here. Sine is opposite over hypotenuse. To find this side, we would use the Pythagorean theorem. So b squared plus x squared is equal to 8 squared. And if I solve it for b, which is what I would call this side, it would be 8 squared, which is 64, minus x squared, and then I would take the square root. I'm going to write this out to the side. X over 8 equals sine of theta. That's how we built our triangle. We've got that missing side here. Let's take and find dx, because when we do a substitution, we have to do a substitution for absolutely everything in that problem. I take the derivative of x, I get dx. When I take the derivative of this side, derivative of 8 sine of theta is 8 cosine of theta. And we took that derivative with respect to theta. So there's your derivative of that angle, which is theta there. We know sines and cosines tend to go together. So let's go ahead and figure out what cosine of theta is based on that triangle. Cosine of theta is adjacent divided by hypotenuse, which means that 8 cosine of theta is equal to the square root of 64 minus x squared. So you can see what our substitution is going to be for that square root is coming from finding the cosine and solving that substitution for the square root. So we're going to rewrite this problem. So we have 1 over that square root of 64 minus x squared, which is 8 cosine of theta. And that is raised to the third power. And then our dx was 8 cosine of theta times d theta. We can see those 8 cosine of thetas are going to reduce in this case. So then I'm going to have 8 cosine of theta quantity squared. And that's really 1 over 64 cosine of theta squared, which is the same thing as, let me pull that 1 over 64 out. And then we're integrating secant squared. And we know the antiderivative of secant squared is tangent plus c. And then we just have to figure out what would tangent be, because we've got to go back from this trig world back into x's. Tangent is opposite over adjacent. So tangent of theta would be replaced by x over square root x squared minus, 64 minus x squared. And then we would have a plus c. So there's my antiderivative. But you can see how this becomes a giant substitution problem, really starting with what we picked for x here, that a sine of theta. And that allowed us to build our triangle, and then we use that triangle to convert everything in terms of trig, because this would be easier to integrate in terms of trig, and then we would go back to x's. Let's look at another problem. Let's say we want to integrate square root of x squared minus 16 over x dx. And we're going to use a trig substitution to help us do that. So this is x squared minus 16. This is in the form of u squared minus a squared. So we would use that secant. Going back up here. Write that out here. We're in the form of u squared minus a squared, which means we're going to use x equals, or u equals, a secant of theta. So we're going to let x equal a, in this case that's 4, secant of theta. So that means x over 4 is equal to secant of theta. That's enough information to build our triangle. So when we set this up, we know cosine of theta using SOHCAHTOA is adjacent over hypotenuse. So secant would be hypotenuse over adjacent. So hypotenuse over adjacent. This side we could find using Pythagorean theorem. So we know 4 squared plus b squared is equal to x squared. So b is going to be x squared minus 4 squared, which is 16, and then I would take the square root. So now let's find dx, because we're going to have a substitution for that. So the derivative of x is going to be 4. Derivative of the secant is the secant tangent. The derivative of the angle is d theta. We know secants and tangents go together. I'm going to go ahead and find that tangent substitution. Based on this triangle, tangent of theta is going to be opposite over hypotenuse. So 4 tangent of theta is equal to the square root of x squared minus 16. So let's rewrite everything. Let's substitute in what we know. That square root of x squared minus 16 is 4 tangent of theta. X we said was 4 secant of theta. Dx is 4 secant theta tangent theta d theta. We see that the 4 and the secant's going to reduce. So this 4 is still going to be there. I'm going to pull it out. I'm going to have a tangent squared here. That's what I want to integrate. Can't integrate tangent squared, but we could do a substitution. We know the Pythagorean identity there. Tangent squared is the same thing as secant squared of theta minus 1. We're integrating with respect to theta. And that is something we can integrate. The integral of secant squared is tangent. And when I integrate that 1, I'm going to get theta because I'm integrating with respect to theta there. And then we're going to have plus c on the end. I'm going to go ahead and distribute that 4 through. So we're going to substitute back in for these guys. We know tangent was equal to that square root of x squared minus 16 all over 4. And then theta is going to come from what we chose for x here. So if I want to get theta by itself, I would divide by 4, and then I would take the inverse secant of both sides. So the inverse secant of x over 4 is equal to theta. Right as arc secant. And then you can see those 4s are going to reduce. So here's my reduced final answer. Let's do another one. Let's say we want to integrate x squared over 1 plus x squared quantity squared. So we don't have a square root here, but we could think about rewriting that denominator in terms of a square root. Wouldn't that be the same thing as the square root of 1 plus x squared raised to the 4th power? So now we're in that form of a squared plus x squared, or u squared. And then we would use a tangent of theta to set up our triangle. So we're going to let x equal 1 tangent theta. So that means x over 1 is equal to tangent of theta. That's all we need to come up with our triangle. This side would be 1 squared plus x squared is equal to the hypotenuse squared. So this would be the square root of 1 squared plus x squared. Let's find dx. Take the derivative of x, which is dx. Take the derivative of 1 times tangent of theta. Derivative of tangent is secant squared. Take the derivative of the angle, which is theta. Secants and tangents go together. Let's go ahead and figure out what secant would be. Secant is the hypotenuse over the adjacent. In this case, it would be the square root of 1 plus x squared over 1, or just the square root of 1 plus x squared. So let's see if we can make some substitutions in here. So we have x quantity squared. X is equal to tangent of theta, so this is going to be the tangent of theta squared. That square root is equivalent to secant, so this would be secant of theta raised to the 4th. And then our dx is equal to secant squared of theta d theta. So you can see how these are going to reduce. So I'm going to have tangent squared over secant squared. Let's try turning things into sines and cosines. So we have sine squared over cosine squared times 1 over cosine squared. You can see how if I multiply that bottom, I'm just going to get 1. So this is the same thing as sine squared. And we have a power reducing formula we can use there. That's going to be 1 minus cosine of 2 theta all over 2 d theta. I'm going to pull that 1/2 out. So I'm integrating 1 minus cosine of 2 theta d theta. When I integrate 1 with respect to theta, I'm going to get theta. When I integrate that cosine, so cosine of 2 theta d theta, we would need to do a u substitution, so we would need a 2 compensate with a 1/2. So this is like my little thought bubble for integrating that. And when I integrate cosine, I get sine. I'm going to distribute that 1/2. So I'm going to have theta over 2 minus 1/4 sine of 2 theta plus c. But our triangle is written in terms of theta, not 2 theta. So we're going to use that double angle formula. Sine of 2 theta is equal to 2 sine theta cosine theta plus c. So I'm going to have theta over 2 minus 1/2 sine of theta cosine of theta plus c. And then all my pieces are going to come from what I have above. So let's see. So we know x is equal to tangent of theta. So theta, if I take the inverse tangent of both sides, is going to be arctan of x. So I'm going to have 1/2 arctan of x. Sine of theta would be x over that square root, 1 plus x squared. Cosine of theta is 1 over that square root, 1 plus x squared. And then plus c. And I'm just going to clean this up a little bit. So we're going to have a 1/2 arctan of x minus x over 2 times, and those square roots means I have 1 plus x squared there, and then plus c. So there's my final answer. Let's try another one. Let's say we want to integrate square root of 16 minus 4x squared dx. So I'm going to think about this one as the square root of 16 minus 2x quantity squared. That way I can use a trig sub. I'm in the form of the square root of a squared minus u squared, which means I'm going to let u equal a sine of theta. So I'm going to let 2u equal a, which would be 4 sine of theta. So notice my u here is that thing that I'm squaring right here. So that means 2u over 4 is equal to sine, which means u over 2 is equal to the sine. So let's build our triangle. Sine is opposite over hypotenuse. To find this side, Pythagorean theorem, b squared equals, b squared plus u squared equals 2 squared. So b would be the square root of 4 minus u squared. So let's look at what we have. We have 2u is equal to 4 sine of theta. So 2 du is equal to 4 cosine of theta, d theta, when I take the derivative. So du is equal to 2 cosine of theta, d theta. So we have a substitution there. Let's figure out what cosine is. Cosine is a over h. So 2 cosine of theta is equal to u. I don't know why I did that. I said a, which was the adjacent, and I wrote the opposite. Let me try that again. Cosine of theta is adjacent divided by hypotenuse. So 2 cosine of theta is equal to the square root of 4 minus u squared. I think we're going to have to tweak this a little bit because we need a 16 there. So let's multiply both sides by 2. So I'm going to get 4 cosine of theta is equal to 2 times the square root of 4 minus u squared. And let's work with this. If that 2 on the outside of the radical really means I have 2 squared here, because the square root of 2 squared is 2, times 4 minus u squared, which means I've got 4 times 4, which is 16, minus 2 squared u squared, which is 16 minus 2u quantity squared. So now we've got a substitution for it. Now, I accidentally changed all my x's to u's here, so just keep that in mind. We could easily fix that by just calling this a for u with respect to u, and then a to u with respect to u. It doesn't really matter what variable I use there. All right, so let's make our giant substitution and turn this into a substitution problem. This is what we were trying to integrate. I'm going to look at this guy. So I am integrating that square root, which is the same thing as 4 cosine of theta, times du, which is 2 cosine of theta, times d theta, which is an 8 cosine squared theta, d theta. We're going to use a power substituting formula for that, or power reduction formula to substitute in. Think about pulling that 1/2 out, reduces with the 8, gives me a 4. So I'm thinking about integrating. We would think about integrating each of these pieces separately. This is going to integrate to theta. This guy is a u substitution. We would need a 2 here and compensate with a 1/2 here. And when I integrate cosine, I get sine of 2 theta plus c. I'm going to distribute. Well, I think I'll hold off on distributing because I see something else I need to do. Use the double angle formula. Sine of 2 theta is equal to 2 sine theta cosine theta. And now that 2 and 1/2 is going to reduce. And now I'm going to distribute the 4. I just have to find substitutions for each of those. So going back up here. If I want to get theta by itself, I would take the inverse sine. So I'm going to have 4 times the inverse sine. I'll call it arc sine down here. The notation means the same thing. Of u over 2 plus 4 times whatever sine and cosine are based on our triangle. Sine is opposite over hypotenuse, so u over 2. Cosine is adjacent over hypotenuse, so the square root of 4 minus u squared over 2. And you can see how we can clean this up. That 4 is going to reduce with that. So we have 4 arc sine of u over 2 plus u square root 4 minus u squared plus c. Let's do another one. Let's say we want to integrate e to the x square root 1 minus e to the 2x dx. So I'm going to start by rewriting that 1 minus e to the 2x as e to the x quantity squared dx. So this is where you may want to try it. Pause the video, try it, come back, check your answer. So this is in the form of the square root of a squared minus u squared, which means we're going to let u equal a sine theta. So our u is e to the x. So we're going to say e to the x is equal to a, which is 1 in this case, sine of theta. So that means e to the x over 1 is equal to sine of theta. And that's enough to build our triangle. Sine gives us those pieces. We've just got to figure out what this is. That's going to come from the Pythagorean theorem. I'll call that side b, b squared plus e to the x squared is equal to 1 squared. So b is going to be 1 minus e to the 2x. And then I'm going to take the square root. Let's take derivatives. E to the x is e to the x dx. Derivative of sine is cosine. Derivative of the angle is d theta. Let's use this to figure out cosine. Sines and cosines go together. Cosine is adjacent over hypotenuse, which means cosine of theta is just the square root of 1 minus e to the 2x. So we've got all the pieces to make our substitutions. So this e to the x dx, e to the x dx is equal to cosine of theta d theta. And then when I integrate that, when I do a substitution for that square root, it's going to be cosine of theta. So I'm really dealing with cosine squared. Use a power reducing formula. Pull the 1/2 out. You make that just a little bit smaller so I can get everything on the same line. And then we're going to integrate. Integrating 1, we're going to get theta. When I integrate cosine of 2 theta, I would need a 2, compensate with a 1/2. Integrating cosine is going to give us the sine. Again, we've got to use that double angle formula there. And that's going to reduce. So I'm going to have 1/2 theta plus 1/2 sine theta cosine theta d theta. Oh, just kidding. I don't know why I wrote d theta. Plus c. So let's substitute in what we know. We've got to solve for theta. So if I take the inverse sine of both sides, theta is going to be equal to arc sine of e to the x. So I'm going to have 1/2 arc sine of e to the x. Sine is equal to e to the x based on our triangle. Cosine is equal to the square root. Oops. Sorry about that. I had a technical difficulty there. 1 minus e to the 2x was our cosine, and then we're going to have a plus c. So there's our final answer. So we're going to do one more. Let's say we want to integrate x squared over the square root of 2x minus x squared. We're going to have to complete the square on this one. So I'm going to do that off to the side. I'm going to factor a negative out. Remember, we have to do that. We have to have a positive leading coefficient there to complete the square. I'm going to take half the middle and square it. Half of -2 is -1. -1 squared is a +1, but we really added a -1 there, so we're going to compensate with a +1. This guy is going to factor into x minus 1 times x minus 1, which is x minus 1 squared. And you can see how this is going to fit this trig substitution nicely. It's in the form of a squared minus u squared. So there's our format. So we are going to let our u, which is x minus 1, equal a, which in this case is 1, sine of theta. So that means that x minus 1 over 1 is equal to sine of theta. And that's all we need to build our triangle. This side's going to end up being 1 minus x minus 1 quantity squared. If we were to do the Pythagorean theorem, I'll let you do that on your own. Let's take derivatives. If I take the derivative of this side, I'm going to get dx. Derivative of the sine is cosine. We took that derivative with respect to theta. Now we are going to need a substitution for x, and that's going to come from this. If I solve this for x, I'm going to get sine of theta plus 1. So let's substitute in everything we know. We're going to have, well, let me just rewrite the problem first. So this guy, that's what we're trying to solve. We rewrote that denominator as the square root of 1 minus x minus 1 squared. So this is algebraically equivalent to that. This is where we're going to make our substitution. I need an x squared. X is sine of theta plus 1. That denominator, if we were to find the cosine of theta, is adjacent over hypotenuse. That denominator is going to be that square root of 1 minus x minus 1 quantity squared. So that's going to be a cosine there. And then dx is equal to cosine of theta, d theta. So let's simplify. I'm going to have a 1/2 plus a 1, which is a 3/2, minus cosine of 2 theta over 2, plus 2 sine of theta, d theta. We're going to integrate. So this is going to be 3 over 2 theta. This is going to need a u substitution. So I'm going to write this way because we're not going to integrate it yet. I'll do it in just a minute. That way you can see that u substitution. And then I can integrate 2 sine. Integrating sine, you get negative cosine. And then we're going to have plus c. So now let's deal with that guy. We need a u substitution to integrate. So I'm just going to write down the pieces that I need for that u substitution. I'm not going to write the full thing out. We would need 2 here. This is u. So we would need a 2 there and compensate with a 1/2 out here. So we're going to get 3/2 theta minus 1/4. When we integrate sine, we get, when we integrate cosine, we get sine. Minus 2 cosine of theta, and then plus c. I don't know what happened to my c there. It must not have written. We're going to have to use a double angle formula here. So 3/2 theta minus 1/4. This is 2 sine theta cosine theta. And that's going to reduce. So let's substitute in what we know. We got to figure out what theta was. I'm going to have to go way back up here. So theta would be arcsine of x minus 1. So we're going to have 3/2 arcsine of x minus 1 minus 1/2. And then we got to figure out what sine and cosine are. Going back to here, sine is going to be x minus 1. And cosine is that square root of 1 minus x minus 1 quantity squared. Minus 2 cosine, which was that square root again, and then plus c. So we could leave it like that, or we could simplify that stuff under the radical. Remember when we completed the square? When we completed the square, we showed that was equivalent to 2x minus x squared. Either one of those would be okay to answer.